Hey guys, here's a video going through the application problem that we started in class today. I'll just go through the whole thing for anybody that wants a recap. So they're going to give you the position function, and they're going to ask you a whole bunch of different questions based off of that position functions. And first thing they'll typically ask is to find the velocity. So to find the velocity, we said the velocity is actually the derivative of position, right? So we go ahead and just use a couple of power rules here, nothing too fancy. And this function actually represents the velocity. Remember, velocity is the rate of change. So if position is given, the rate at which that position is changing with respect to time, that would be your velocity. And they're going to say to maybe find the velocity at particular values of t. So v of 2, just plug in 2. And I think that one ended up being -3, and we'll go meters per second for our units. V of 4, I believe when you plug that in, you end up getting 9 meters per second. And that's A, that's B. And all it is just finding the actual values for the velocity. All right, let's see what's next. Next question is to find when the particle is at rest. So when the particle is at rest, the velocity would be 0, right? It'd have no velocity there. So we set v of t equal to 0, which is our velocity function, which factors nicely. I believe this was t minus 3 and t minus 1. So at t equals 1 or at t equals 3 seconds, the particle is at rest. Okay. And let's see, the next question is, when's the particle moving forward? So if the particle is moving forward, we consider that to be positive velocity. So I want to see when is the velocity greater than 0. Okay? Oops, move that out of the way. So what I like to do is I actually like to, I'll look up here. I'll look at this velocity equation in factored form, and I'll set up a little number line. So I'll use all these numbers that I know the particle stopped at as sort of my breaking points. So t equals 1, t equals 3, and technically the particle started when t equals 0, started moving. So I'll use 0 there too. And this is my velocity number line. And then you just check values on each of these intervals. So between 0 and 1, if you try a half, you get a positive times a negative times a negative, which is positive. Plug in 2, you get a positive times a positive, that would be negative. And plug in like a billion, positive, positive, positive. And this immediately tells you whether the particle is moving to the right or the left based on the sign value of the derivative. Okay, if velocity is positive, particle moves to the right. Velocity is negative, particle moves to the left, etc. So they asked, when is the particle moving forward? So the particle is moving forward on the interval from 0 to 1 and from 3 to infinity. Okay, we include the 0, that's sort of the starting point there. I typically don't include the values where the particle is at rest, however that is debatable, but that's the concept. All right, when the velocity is positive, you have the particle moving forward. Velocity is negative, the particle is moving backwards. Okay. Next question is they want to know, or they want us to draw a diagram that represents the particle's motion. Okay. So to do that, I do what I call like a snake graph. Okay, so this is where I just refer to it as a snake graph because it ends up kind of just looking like a snake. So we kind of know what the particle is doing from this number line here. We know we're going to the right, then to the left, then to the right, but where are we? So what I do is you start at t equals 0 typically and figure out where you are. Well, how do you figure out where you are? Go all the way back to the original function, which is the position function. So at t equals 0, my position is 0. Then what happens? Then I go to the right. How far do I go? Well, I go until t equals 1. So t equals 1. Well, where am I at t equals 1? Oops, I didn't mean to put a 1 here. Where am I at t equals 1? Well, I plug it in and I get 1 minus 6 is -5 plus 9 is 4. So I'll write it over here. S of 1 is 4. So S is 4 there. So I've gone 4 meters to the right, essentially, to start. Then what happens? Then you come back to the left. How do you know? Look at the number line. From 1 to 3, I know I'm going to the left, so I'm going back. And then the only question is, well, how far back? Well, to answer that question, I need to figure out my position at 3. If I plug in 3, I get 27 minus 54 plus 27 is actually 0. So I end up right back at s equals 0 when t equals 3. Then what happens? Then I go back to the right. How far? Well, indefinitely. And what you'll notice is, this isn't on like a graph. There's no spacing, scaling values here. There's no grid. I'm just giving the general flow of what's happening to this particle. It moves from 0 to 4 to the right, then it goes from 4 back to 0 to the left, and then it goes from 0 to wherever to the right again. And all that information came from using the velocity for the direction and the position for the actual location of the particle. And that's a snake graph. Okay? And then the last question for this part is find the total distance traveled by the particle during the first 5 seconds. All right, well, I already kind of know what it did during the first 3 seconds, right? I went 4 meters this way, 4 meters that way. So the question then becomes, well, how far did I go in the first 5 seconds? So this is 4 meters, this is 4 meters. So for F, I kind of also want to know where I am at 5 seconds. So if I plug in 5 up here, S of 5, it looks like 125 minus 150 plus 45 is 20, I think. So at 20. So if I were to add just one more point onto this snake graph, using it for part F, I would have I would have T equals 5 and S would equal 20. So I go 20 more meters for that last leg of the trip. 4 meters this way, 4 meters back, 20 meters this way for a grand total of 28 meters total distance. All right? And that's essentially how you set up a snake graph using velocity and position. And I'll make another part of the video for the acceleration portion of this topic. But if you have any questions, be sure and let me know, and I will talk to you later.